Authorization Code with PKCE, pronounced pixy. This is the modern standard that replaces the static client secret with a dynamic cryptographic proof. OAuth 2.1 mandates PKCE for all authorization code flows. Before anything else, the client generates two values. First, a code verifier, a high-entropy random string. Then a code challenge, the SA256 hash of that verifier, base 64 URL encoded. The verifier stays secret. Only the challenge is sent initially. The client redirects the browser to the authorization server, including the code challenge. If an attacker intercepts this, they cannot derive the original verifier because SHA-256 is a one-way function. The browser navigates to the authorization server. The server stores the code challenge and associates it with this authorization session. The authorization server presents the login and consent screen. Behind the scenes, it has saved the code challenge for later verification. The user enters their credentials and approves the requested scopes. As always, the password goes only to the authorization server. The authorization server redirects back with an authorization code. Even if a malicious app intercepts this code, it cannot exchange it for tokens because it doesn't have the original code verifier. The browser delivers the authorization code to the client application. The client now has two things: the code from the server and the code verifier it generated at the start. The client sends the authorization code together with the original code verifier, not the challenge. This proves that the entity exchanging the code is the same entity that initiated the request. This is the core PKCE mechanism. The authorization server hashes the received code verifier and compares it to the stored code challenge. If they match, the request is legitimate. Verification passed. The server returns access token, refresh token, and ID token. No client secret was needed. The dynamic PKCE proof replaced it entirely. The client accesses the protected API using the access token in the authorization header. The resource server validates the token and returns the requested data. The entire flow is complete. Key takeaways. PKCE replaces the static client secret with a one-time cryptographic proof. The code challenge is a one-way hash. Intercepting it is useless without the verifier. PKCE protects against both code interception and code injection attacks. It's safe for public clients like SPAs and mobile apps because there's no secret to store. OAuth 2.1 mandates PKCE for all authorization code flows. Even confidential clients benefit because PKCE proves session binding, not just client identity.